Yep.
The first ones to get a cloud.
Apparently, did we just wait long enough? Right, so just quickly we're going to do a sort of a brief, very bigoted history of kind of cloud, in a sense. So, like, if you wanted to run something on the internet, you used to have to basically, get some hardware, maybe throw it into a data center because that's where the tubes were. But it was your hardware, and then you had to, look after it, patch it, upgrade it, and eventually people started asking the question, well, this is not really our core business, right? Unless you're actually a data center or something like that, it's not a thing you want to spend all of your time focusing on. So along comes Amazon with their EC2 and S3 services. Again, highly sort of bigoted, streamlined history. But they basically they say, we'll give you VMs that you can basically spin up and do exactly the same thing that you would have been able to do in a data center with your own kit. So you don't have to maintain any of that hardware. You're not going to have to maintain even if you're into virtualization, you're not going to have to maintain any of the hosting systems at all. You're just going to be able to spin something up, pay for it, spin it down when you don't need it anymore. And obviously that's quite appealing, particularly if you if your core business doesn't require physical hardware, which it turns out a lot of people's don't. This can be quite an effective thing, particularly if you, when the alternative is spending, you have to buy to your capacity and then just have this kit sitting around, for weeks, months, years that you now got to sort of carry around. Even if you're like a retailer who, for 2 weeks they have this much load, and the rest of the time they have, just a very little amount of load. So it's sort of the economics work out very well with sort of virtualized solutions. And sort of since then, we've just kind of seen a trend towards giving up control of the lower levels in exchange for basically a cheaper service, right? So instead of having a full-time virtualized operating system, you're like, well, actually, I just need something that'll host a container, sort of virtualized operating system, or I just need something that'll host like a runtime. And I guess functions as a service sort of represents the culmination, I guess, of that idea. The idea that if you don't need any control over the lower layers of your operating system, your virtualization, your runtime, then you know what? Like, why spend any time worrying about it? Why worry about, creating load balancers and scaling load across all of these things if your problem doesn't really need that sort of thing? And there are plenty of problems that still do. So functions are functions are good for some things, and they're not so good for other things. Functions, first of all, all they are is a little bit of compute in the cloud, right? So you've got no control over anything else. You don't have any state. Not really. I mean, you can technically throw something onto that tiny little virtualized bit of storage, but it's transient. Don't do that. So functions really have to exist in a broader ecosystem. They exist talking to cloud databases like CosmosDB or SQL, the Azure SQL storage. They exist talking to, or virtualized databases. They exist talking to third-party services. They're not much use on their own, really. All they can do is do a bit of computation. So I guess you can sort of think of them, like if you think of microservices, that's kind of the space that you're looking at. You're looking at possibly glue code, things that get triggered by one thing, do a bit of work, maybe output it to something else. And so the whole metaphor for that, for functions, generally works that way. You don't, you write a bit of code, and you're generally provided a framework that gives you bindings to input-output. So in Azure, obviously in Azure there's kind of three kinds of bindings. You've got trigger bindings, inputs, and outputs. Triggers are basically like a web trigger. I'll let William go into the details of the other triggers. But send a web request, function spins up, does some work. Outputs, again, are wiring through to external entities, whether that's a database or an event queue or something like that. Oh, yeah. I'm not quite sure why in this day and age we have screensavers, because that's kind of a cathode ray tube thing. Yeah, I genuinely don't know. But anyway, so this diagram kind of shows this trade-off. But there's kind of an implication here, which is that they're really not good for anything really heavy. They're sitting in this kind of big pool. You can get kind of dedicated functions, but they're sitting in a big pool of shared compute. So they're not going to be churning through. They're not going to be cracking passwords, for instance. You wouldn't do rendering, anything that would require serious processing. That's kind of not their jam. Similarly, they tend to be transient. So if you've got something that needs to last for a long time in a function, you're going to have to put a whole bunch of stuff around that, right? So, like maybe you've got an event worker that's sort of coming in, sending events. You don't want to be picking up an event and doing, 20 minutes of codec rendering. Say someone puts a video in a place. Your function needs to basically be kind of get in, get out. So if you wanted to do codec rendering, for instance, you'd probably have to find a way to kind of be prepared to do resumes and that sort of thing. Is everyone sort of following me here? So they're not big, they're not long running. The timeouts tend to be quite short. I think there's a 5-minute timeout by default on a single function kind of instance, and I think they can stretch to 10 minutes.
Yeah, so basically, I'll cover that maybe.
Yeah. Sorry, William's going to go into the details of Azure Functions. I'm sort of talking more generally here. Generally, they don't last a long time, and their big virtue really is that they're cheap and they're on demand. You're only kind of paying for the time that a container spins up and serves requests. You can ensure that the container is always up, but even then you don't have a lot of compute available to you. So it's really really cheap, and it's really really scalable, right? Because you've got these tiny little stateless things. You can your host will spin up as many instances as it feels like it needs to actually match that demand. So if you've got a small, scalable problem and you don't need any of the control that the other options provide, then functions are exactly what you need. I'd use them in places where I was doing glue code, so where I needed to do, I had stuff coming off an event queue that I needed to quickly do a bit of processing on, maybe like grab an image and render it out to 3 different sizes of image, or maybe quick little microservices which take a single web hit and sort of lean on a bunch of existing infrastructure that you talk to. They could glue between 2 services. William's kind of going to show us how he talks to a third-party service to takes advantage of functions to use a third-party service. They're a great little tool for an existing kind of cloud world. Yes.
Well, how's the difference in between functions and what?
Between functions and
Flow.
I don't know what flow is. Sorry.
Microsoft Flow.
Microsoft Flow.
So that's kind of Logic App C predefined logic apps?
Yeah, that's a good question, actually.
Because you can design your own by, when something happens over here, you can do either put it there,
Yeah,
or send it to a third app.
Ideally, each piece or each step of the flow item would be a function. So, and you wire those together.
Now, I do know that the WebJobs functions, Azure Functions use the WebJobs SDK, so they do use a lot of very similar concepts. I believe they use the same sort of binding stuff. I'm not familiar with Flow.
So is that Flow more of a orchestrator kind of thing where functions actually orchestrator? Yeah.
Yeah. Though interestingly, Azure Functions are sort of exploring a little bit that way. They've got this durable functions thing, which is basically allows them to orchestrate a number of kind of subsidiary or child functions over a period of time.
Or if I was to say then, how does functions compare to Zapier?
Oh, Zapier. Well, actually, no, I think they sit in a very similar space.
Because Flow's like Zapier.
Right, okay.
So Zapier and Flow is more of a SaaS. So what it does is that it helps you to orchestrate different services together, whereas functions is more of a PaaS where you can build on top of it.
Yeah, so when we talk about functions, we are talking about your code. It's you're writing JavaScript or C#. You're not like my understanding is those things are very much defined for data transformations, right? They're all about you get an input, you transform it in some way, and you do and get an output. This gives you just a little bit more control than that, but a little bit less than your own web app, for instance. Yes, that kind of covers my part of the thing. I'm going to hand this over to William, and William's going to show us a little bit about the Azure Functions platform, which is similar to the AWS Lambda platform. We're going to be focused on doing it Azure native. It's worth knowing that it's still very early days for this kind of this ecosystem, but it's worth noting that there are already frameworks like the Serverless Framework that allow you to write in a cross-platform way. So if you're a JavaScript developer and you don't want to be locked in to a specific vendor, it is possible to do that, to write your compute and then rely on a framework to make sure that you can actually switch if you need to. That said, we're going to talk about Azure Functions.
Yeah, so just follow what Daniel just said. I think it's kind of what Brenda said earlier on as well. So when you actually use Azure Functions, you're kind of tied with the technology. But I kind of disagree with that because Azure Functions runtime is actually open source.
Do you want Shall I clip you in and you go?
This is actually open source framework, which means you can deploy your Azure Functions runtime into anywhere, right? You could deploy that into your own data center, for example, and you can still develop it using C# and develop the functions in there and deploy it into your own data center. Anyway, that's my opinion.
Yeah, sure. Do you want to grab the...
Cool.
Right.
Cool. All right. So just before we start, and just quickly introduce myself. My name is William Wang, and I'm one of the technical specialists working at IAG Digital Platform, and that's my contact details over there. So today we got a few colleagues of ours, like we got Daniel here, David, Darren, Jaco as well. So David is one of our senior developers with a digital platform, and he's been doing a lot of Azure stuff. So if you during the hands-on session, and if you do have questions, just you can always refer to David. Do you want to say something or? Wave your hand. Cool. All right. Should we just get started? So Azure Functions. What is Azure Functions? Basically, Azure Functions is an event-driven serverless compute service that runs in the cloud and that's basically let you to run some piece of code or small piece of code on demand without having to provision any infrastructure. So it's basically, it takes the pain away from you to managing any infrastructure and let you to be focusing on writing code or writing your business logic. So you no longer have to basically, like what Daniel mentioned, you no longer have to maintain any hardware or any, server operating systems. So that in that sense, in the case you have your own server and you have to maintain or install updates or security updates and stuff like that. So what that means is that, in the case you have to restart your computer or server, that means you have to have some downtime for your application, of course, right? So with being a serverless architecture, it's kind of, Azure as an ecosystem that solves all those problems for you, all right? And another good thing about Azure Functions is that it basically uses a pay-per-use pricing model. So what means is that you only pay for the time your code runs in Azure, plus the number of executions that you have in there. So it's really super, super cheap. I mean, you're probably talking about 1 million executions for about 20 US cents or something like that. So that's how much you're paying for that. Of course, plus the number of the time that your code runs in there. All right. So just another thing is about Azure Functions that I want to get the terminology right here. So when we talk about Azure Functions being a service or product name in Azure, where with the when you actually create an Azure function, you're actually creating an Azure Function app. All right. So with the Azure Function app, you can have multiple functions inside the Azure Function app. So if you're familiar with, let's say, .NET Web API development, right? So when you create a .NET Web API project, it's a project that you can have multiple controllers in there. With Function app, it's more or less equivalent to a Web API project. And then with the functions, it's what you have as a controller. Because with a single function, you can have multiple operations like HTTP GET or HTTP POST and those sort of things. So the other thing is about Azure Functions is that Azure Function app behind the scenes is actually runs inside a container. And at the moment, Azure Functions runtime version 1 is runs on the top of full.NET Framework 4.6 and on the top of IIS. All right, so when you and Azure Function app, when you deploy it, it's actually deployed to a single container. And so keep in mind that when you have multiple functions inside a function app, they all share the same resource of the container. So in that sense, if your function becomes, or function app becomes really, really large, it's better to start breaking them down because you may hit some resource limitations when you actually, when you have a big mono application in there. Right, so that's basically what a Azure function is in a nutshell, and it's basically code plus events and data makes Azure functions. All right. Next slide. So the next thing is key features of functions. So it's basically the first thing is about choice of language, and you can write functions in multiple languages, and you can pick one that you're familiar with. So at the moment, there's, like I mentioned, just 2 function runtimes available. Function runtime version 1 that has been GA'd or generally available for 1.5 years probably, and then version 2 runtime just been released. I think it was late last year, and it's still in preview mode. So with version 1, you got 3 languages support. It supports C#, F#, and JavaScript. And with version 2, it got a few more languages added, like PHP or Java. If you're coming from Java background, you can also develop functions using Java, and also PowerShell, and I think Bash as well, probably. So with version 2, it's also a .NET Core, runs on top of .NET Core framework, so which means you can actually deploy your functions into Linux as well. All right. Pay-per-use pricing model, so that's what I kind of just mentioned earlier, and that's, you only pay for the time you use, run your function in Azure. and bring your own dependencies. What it means is that when you develop any .NET application, you can reference your own npm packages or NuGet packages, and this is the same thing like when you're writing functions. You can always use NuGet packages in there, or let's say Newton soft JSON or whatever, those serialized or DLLs or whatever. It's actually the Newton soft library is actually part of the functions template even. Integrated security. So in the case you say, let's say you're developing some sort of web API or microservice using functions HTTP trigger. You develop your API and you deploy it, but the thing is that once you deploy it, everyone can access it. So in the case you want some sort of protection on your API, what you do is out of the box, Azure gives you something called gives you the lets you to integrate with a whole bunch of OAuth providers, let's say Google account or Microsoft Azure Directory or Azure Directory, Active Directory. Or Twitter even. So you can integrate functions with those OAuth providers to be able to authenticate your user. Or to make it simple, function also supports something called function keys, or similar to API keys. So in the end, you get a key, and when you request the function, you actually just put that key as part of your HTTP or request header to be able to access functions. Simplified integration, that's again, it's about integrating or using Azure Functions to integrate with other services in Azure or PaaS offerings in Azure. Let's say, integrate your functions with CosmosDB or Service Bus or blob storage, all those sorts of things. So it's all available in there. Zero downtime deployment. All right. So zero downtime deployment is basically something that lets you to deploy a function without having any downtime. And with Azure Functions, it's kind of inherited from the app services in Azure. So it's using deployment slot. So basically, a deployment slot is you think of that as a clone of your production instance. And it's got its own host name and stuff like that. It's just a same thing, the same slot as your production slot. What you do with the deployment slot is that when you actually develop your function, you create an offline slot or staging slot, and you firstly deploy your application into the offline slot, and you can do whatever testing you want to do, right? Let's say your BDD tests or run menu tests against your API, right, or your application. And once you are kind of happy with the outcome, and you can just simply do a slot swap. So what it means that you just simply change the offline slot behind the production slot, and the production slot become the offline slot. So the good thing about with doing this kind of deployment slot is that in the case, let's say you've kind of turned a new version into production, and things happens like you may find some issues in the production slot. So you can simply do a slot swap again to basically slot the old version back into the new into the production slot as a good rollback strategy. And then open source. Basically, Azure Functions is open source. That's what I kind of mentioned earlier. So it's available on GitHub. If you want to say, I want to deploy Azure Functions runtime framework into my own server, you can do that and deploy your functions into it. You can do all those things, but I don't know why you would want to do that, but you can if you want to. All right, function triggers. So function triggers, out of the box function has many built-in triggers, and this is just some of the common ones that I found on the internet. So basically, the way I understand triggers is that how you actually want to run your function, or how your function is being invoked. All right. Each of these triggers kind of designed for different use case scenarios. So let's just quickly maybe go through a few of those. HTTP trigger, then you just quickly mentioned that. It's basically a way that you just send a HTTP request to your function, and then that's how you trigger your function to run. This is probably one of the common ones that mostly used for developing APIs or microservices. The second one is a timer-based trigger. So a timer trigger is basically you execute a function based on a predefined schedule. So if you are familiar with Windows Server-based schedule tasks, or what you do is basically create a schedule task and in Windows Server, and you run that on a predefined schedule. So this is kind of working a similar way like that. Again, back onto Daniel's points that most of the cases, like in the real world, or traditional way, that people having this kind of things it's basically you have a server that provisioned just for this purpose, and it's super underutilized. It's basically the server sits there and ticking the clock until maybe you want that schedule to run or function to run once a month, and it's actually all the rest of the time is actually wasted computing resource over there. All right, the blob trigger, CosmosDB trigger. CosmosDB trigger is, let me just quickly talk about CosmosDB first, and before we talk about CosmosDB trigger. So, CosmosDB is a NoSQL database. It used to be called DocumentDB a couple of years ago. So it's kind of it's designed it's a globally distributed database and designed for super high throughput with Microsoft says single-digit millisecond latency. So which means it can handle millions of requests per second. With CosmosDB trigger, CosmosDB itself supports something called change feed API. So with the change feed API, is an API that you can queue or call, or you have some sort of application that can poll the change feed API to be able to see the changes that going into the database. So for example, if you create or insert a new document into your CosmosDB, and you have some sort of application that polls this change feed API, what you get is the newly inserted or updated document from the other side, right? So with the CosmosDB trigger, it basically wraps this change feed API. So instead of doing a poll of, if you use some sort of console application to keep polling the API for changes of CosmosDB, you can actually use this one as using Azure Functions to basically let Azure to handle the polling side, or actually doing a push probably in the behind the scenes anyway. So in this sense, it's a lot. It's more efficient than polling, I suppose, with CosmosDB trigger. Blob triggers are kind of similar to CosmosDB trigger. So where CosmosDB is like a NoSQL database, that you store JSON files in there, right? And with blob trigger, you can basically store any kind of files or even binary files or images, stuff like that. Queue trigger, service bus trigger, or topic trigger. The rest of the triggers kind of works basically similar way as CosmosDB trigger or blob trigger, but they do have subtle differences between those technologies, and then they're designed for different use case scenarios. So I'm not going to details about those ones, but you just keep aware those triggers are out there available, and then custom trigger was something if all those triggers listed over there, you can't find the right one to use, then you can always develop your own custom trigger. So let's say at our company we tend to use service bus topic trigger, but there are certain features or limitations in that trigger, and we basically came up with our own way of subscribing to service bus subscriptions or topics. All right. So that's about trigger stuff. Can you guys see that, right? Or you probably don't have to see it anyway. So this, I don't know what happens up top there, but anyway. So this table basically shows you a complete list of triggers and input and output bindings that you can do with the Azure Functions, with the 2 function runtime versions. All right. So as you can see, there are things that used to be. Sorry, just quickly point out. So that version 1 and version 2 of Azure Functions Runtime. Right? So as you can see, there are things that used to be available in version 1 of Functions Runtime, but no longer in version 2. But because version 2 is still in preview mode, so there may be things coming into version 2 later on. But that's as of today and what are supported in version 2 at the moment. And we just talked about the trigger stuff, and then input and output binding. So again, that's basically something that you can use functions to easily integrate with other PaaS offerings in Azure. So like, for example, with input binding, if we take a CosmosDB example, input binding is basically something you can specify. Let's say with CosmosDB, you have some sort of inline script that you can pass in a select query. So in that case, when your function runs, it actually goes into CosmosDB and do a, let's say, select star from my collection, and you get a whole list of documents back. So that's how you do input binding. And then with output binding, it's basically when your function runs, it's designed for basically writing data back to persistent storage, let's say CosmosDB or blob storage. So when your function runs, and it stores the file back to the persistent storage. All right?
I work in a dynamic CRM. I see you've got Outlook there and Excel.
Yep.
Is that cloud-based Excel? Or
To be honest, I don't really know the answer to it. I've never worked with those either input or output binding for
I see you've got
Excel
Microsoft
stuff.
Graph there, so I'm thinking, okay, maybe there might be a connection there to CRM.
Yeah, I suppose so. But I never tried. I mean, this is basically a complete list of things that's supported in functions. I have really limited things, like I've worked with CosmosDB or HTTP trigger stuff, but not so much on the graph side of things or upload. So,
Okay.
yeah. Cool. All right. Yeah, pricing model. So yeah, we kind of been talking about consumption and as basically you pay what you use, right? So we've been talking this quite a bit. But yeah, so again, like with consumption plan, Azure provides you all the computing resource that you need for your function to run on. So you no longer have to worry about the resource management. And from the infrastructure perspective, Azure Function gives you something called scale controller. So the main responsibility of scale controller is to basically ensure that your function runs on demand based on its load. So in the case there is a spike or high volume of traffic flooding into your function, the scale controller will be able to figure out if it needs to add more instances or scale out your function app. So that's basically what it's designed for. And again, like take a web API as example. So if you have a high amount of traffic that going into your function, and the scale controller will simply look at your function apps containers CPU usage or its memory usage. If it's constantly getting 100% or 90%, that definitely a sign that for the scale controller to start scaling function app out. So basically adding more instances to it. And with scale controllers, things that it does scale out or in, but it doesn't scale up or down, which means it doesn't give you bigger virtual machines or bigger containers for your function. All right, so on the opposite side, it's basically Azure Service Plan. So with Azure Service Plan, it's more or less similar to what we used to be doing. Is like conventional web farm hosting stuff, right? So what you do is when you create an app service plan, you actually have to specify how much CPU or memory that you want for your function or function apps to run on. So with app service plan, you can create a single app service plan, but having multiple function apps runs on the same app service plan. So basically, that's how you can actually save a little bit of money, I suppose. And also, you have the flexibility to do scale up or down. So because app service plan is gives you all the flexibility to scale out and in and up and down as well. But the thing is that you have to be responsible yourself to do all those things. So you can set up rules that to scale out or scale in, those kind of things. So very. On the other hand, it's about the sorry. No, let me just check. So I forgot to mention about the consumption plan. Where, in the case the scale controller, that's we talked about scale out, but we didn't talk about scale in. So with scale in is with a scale controller when it sees the load kind of drops on your function app, it starts scaling things back to 0. In those cases, you have to be careful that function runtime, it does take a little bit of time to warm up. From my experiences, like anywhere between 15 to 40 seconds to warm up a HTTP-based function app. So in that sense, you may want to think about having a pinger kind of application that can keep pinging a function app to keep it awake. So that's something, be careful on that side. Right, so deployment, I suppose, so once you finish, let's say, you're developing a function and you tested everything locally using your Visual Studio or whatever, right? And now it's time for you to deploy it. Basically, I got 3 things in there, but there are more options there are more ways that you can deploy a function. So the first one I've got there is basically right-click from Visual Studio. So that's basically the simplest way that you can deploy Azure Functions. So what you do is after you create a function app in Visual Studio, and you just right-click on your project and then click on Publish, I think, and just follow the wizards from there to deploy your function. That's not really the best approach to deploy things, but that's the quickest way to get something up and running in Azure. All right, the second one is called deployment options. That's an option that available in Azure portal. So what you do is to basically configure the deployment option to pointing to your source code, is either GitHub or VSTS or even Dropbox. So whenever there is a change made to your repository or source code, Azure is actually automatically do a build and deploy a function straight away. So this is definitely not the best way, and that's definitely a no way, to be honest, because it's kind of doing a simplified version of continuous deployment, but you literally pushing, it's got a lot of limitations in there, so you're literally pushing your source code straight into a live environment without running any tests, right? So it's a great way that, if you talk about Microsoft demos or sales page, and it's a great way that how easily you can set up something continuously deploy, but it's not really practical in the real world. The last one is continuous integration and continuous deployment using VSTS pipeline. So I suppose that's the best way from the CI/CD perspective to deploy your application. And I kind of mentioned VSTS there is because VSTS is being a Microsoft product, and it's got a lot of great integrations with Azure's technologies, right? But you're not kind of limited with VSTS. If you are familiar with, Jenkins or Bamboo or those orchestrators, you can always replace VSTS with those tools in there. And another point is infrastructure as code. So I suppose this infrastructure as a code is basically a way that how you can store your infrastructure code in a kind of Git repository or whatever source code repository that you use, right? So in that sense, you have all your infrastructure code in there that you no longer have to, when you spin up new environments, you no longer have to manually or follow a big, long implementation document to set up your environment. And you can just use your infrastructure code to spin up new environments in an automated fashion. So the good benefit on doing that is that, you kind of guarantee that all your environments are going to be the same. Let's say dev test or pre-prod or production environment, they're all the same. So that's the beauty of using infrastructure code. And every resource in Azure is support infrastructure as code or infrastructure code. So what you do is to create something called ARM template. It stands for Azure Resource Manager. So with ARM template, it's literally a JSON file that you can configure your infrastructure. So there is a good GitHub repo that's called Azure ARM Template 101 or something like that. That's where you can find all different sort of ARM templates in there that you can use to deploy functions, or you can deploy app services, VMs, or whatever. Yeah, I think I've got only covered one slide, I think. Yeah. All right, so that's about deployment. And then limitations. I think this is my last slide, I suppose. Yeah, so limitations, this is more around the Azure consumption plan related functions, or functions related to consumption plan. So the first one is a 15-second cold start. So yeah, again, like I kind of mentioned that, when the case that scale controller scales your instance or your function app's instance back to 0, it does require bit time to start your function again. So that's where that's why I put the 15-second cold start in there. The second one is a 5-minute timeout, max up to 10 minutes. So what it means is that with Azure Functions running in consumption plan, the maximum time by default you can run your function is 5 minutes. If you want to extend that you can do that to extend that up to 10 minutes. So that's the maximum time you can run your function. So if you want to go, if it goes beyond that time, Azure is actually going to kill the function for you. All right. But if you do need that to run longer time, then you do have the option to use app service plan to run your function. But arguably, or in my opinion, if you have anything that needs to run that long, probably Azure Functions is not the right technology choice to solve your problem. All right. 10 seconds to scale out. So that's something like with a scale controller, it only looks at your your containers load every 10 seconds. So that's what it means. That basically means minimum time that for your function app to scale out is at least 10 seconds. All right. The other one is 200 instances for your containers. I'm not sure if that's a limitation, but there is the max number of instances that you can go with as 200 instances. So, but I don't think if there's any API or application that will require that many instances to run. And then 1.5 gig of RAM and a single core. That's basically what you get with by default with the Azure container, and that's how many or how much memory or how many CPUs that you can go. But in the case it does need more, then you obviously got app service as an option. All right. Yeah, I think that's basically my last slide and the end of my presentation. Question?
That's the maximum scale out that Azure Function entities have. What's the reason for those limitations? Why doesn't it why would you not just scale outwards? I mean, I understand you might want people to buy the app service plan, but is there like any kind of technical limitations as to why you shouldn't scale out further?
I think it's a good neighbor thing. If you're using consumption, a good neighbor thing. If you're using consumption plan, you're all of that compute's happening on a single shared scale unit like box, which means that basically I think they sort of allocated that much. Probably if you're using consumption plan, I mean Microsoft's answer has generally been, pay for the premium thing. So they'd probably, if you are using enough capacity that you'd hit that limit, they'd probably suggest an app service plan. Otherwise, I mean, I imagine it's a soft limit on that 200.
So I must have missed that. So the Azure functions are shared instances. Sorry, the functions are shared. The compute is shared on the same box.
Yeah. So for consumption, they're all on the same scale unit, and if you're in an app service plan, you'll be. Again, that service plan sits on a scale unit that is shared, but you have allocated resource available to you, as opposed to just.
Do you have the whole of that unit, or do you share that unit with other customers?
You share that unit. Oh.
No, you don't share that
Not
unit,
during
right?
your process.
It's a-
No, not during your processing.
Yeah.
The actual, like, you don't, there's no leakage, it's all sandboxed.
Right.
But just like any cloud service, you're sitting on a shared layer of infrastructure.
But it's dedicated to you during execution.
Yes,
Yeah.
correct. Yeah.
I mean, still behind the scenes, you get dedicated VMs, no matter you run consumption plan or app service plan, right? Because app service plan is also dedicated VM, and you just basically have the flexibility to say how much memory or how much CPU that I want. But with a consumption plan, out of box, it only gives you 1.5 gig of RAM plus a single core CPU. Yeah.
But if you had that sort of spurt once a week
Mm-hmm.
or once a month only, that's the only time you ever use it. I
Mhm.
appreciate being on shared, but what if you need to have that extra oomph? once
Well,
a
I
month?
mean, again, this comes down to your use case. If you're needing to scale up, 200 servers in a short period of time, and then scale back down again.
Switch it on, run it, switch off.
Yeah, I mean, yeah, you could do that.
Yeah.
Service plans, I'm not sure I think they've got a daily.
This daily,
ticket.
the minimum unit is a daily, I think, for app service plan.
So if you want,
That's not
paid
really-
by the second.
not for app
No.
service plans, no. For consumption, it is.
For consumption, consumption is basically the amount of time that your code that runs in Azure plus the number of executions. There's a good Azure calculator and online that you can use. Yeah. So basically, you specify you pick what sort of service that you want, and then you give different type of plans and stuff like that. Yeah. Sweet. Any more questions before we carry on? What do you call that? Fruit URL and the full URL for my GitHub repository. So you got a README file in there basically, and that's how that's basically you can follow to do the 4 items on the top. So the first one is basically teach you how to create a Azure function using Visual Studio, and then how you deploy functions to Azure. And then after that, we can just go and create a CosmosDB from Azure portal, and then you can use the CosmosDB input or auto binding to basically set an API that you can have a bit, as a CRUD kind of operation API, create, read, or delete kind of thing, using Azure functions.
So before we get started, is there anyone who doesn't have Visual Studio 2017 relatively up to date?
Everyone
has? Oh, we've all done this?
Yeah.
Cool. Oh, sweet. Perfect.
Cool. So we got helpers here, and if you guys need help, and just wave your hand, and got David and Darren probably as well. Yeah, cool. Yeah.
Thank you, guys.
It's okay.
Was there a comment about Azure Functions being infinitely scalable?
Infinitely scalable.
Infinitely scalable? I thought there was a...
No, I don't think that's the case.
Yeah.
Well, unless you
Well,
are
if
on
you're
app service
Azure,
plan,
I
right?
thought it was part of the Microsoft sales sheet.
I think
I mean, if you have
probably
infinite
can
dollars,
do,
they probably are infinitely scalable.
you can probably do that with app service plan.
We need to have that, is that Postman
Postman, sorry.
integrating into the Visual Studio files and background stuff?
No, he's just using it to send a thing.
It's just a
So I can run it on Chrome on my
Yeah, run
Linux
Chrome or Curl.
access the
Yeah, as long as you can access it on a network, there's no special requirement there. It's just gonna
Maybe Neil would use it every day.
it's just gonna pop Visual Studio on the screen.
Just keep going. I've just got
Okay.
my PC
Oh, cool.
for the next session,
Yep. Cool.
for the wraps.
Right.
So no problems.
What do you?
I'm going to walk